Hey guys, Mr. Betts here. I want to talk about the extreme value theorem, which was from a couple of topics ago, and combine that with some ideas that we've talked about more recently and how we can actually find the extrema guaranteed by the extreme value theorem. So, first, I want to talk through some things that we know. We either know that they're true because they're theorems that we've talked about already, or things that we could assume to be true. So, first of all, we know the extreme value theorem that says if a function is continuous on a closed interval, then it must have a maximum and minimum on the interval. So, this is talking about a global maximum and a global minimum. We also know that local extrema must occur at critical points. So if we have a local minimum or a local maximum, it's either going to be where we have a horizontal tangent where the derivative equals zero, or we're going to have some sort of non-differentiable point at that point. So those are going to be critical points. So our local extrema are going to occur at critical points. Some things that we can assume. So first of all, a global extreme is also going to be a local extreme. So this one might be kind of obvious once you think about it. If we have some function here on an interval, and it doesn't even have to be on an interval. Let me do something like that. So this point right here is the global maximum. Being a global maximum, it's also going to be, just looking at the neighborhood around it, it's also going to be a local maximum. So any global maximum or global minimum is also going to be a local minimum or maximum. So that's going to allow us to tie this into the extreme value theorem. And then the last is, if we have a closed interval, and I'm going to make this as simple as I can here, an endpoint could be one of the extrema. It could be a maximum or a minimum. So this is a continuous function on a closed interval, and the absolute maximum occurs here at the endpoint, and the absolute minimum here occurs at the endpoint. So we could have extrema that are at the endpoints, not just interior points on the interval. So putting these ideas together, we can come up with some process that we can find the extrema that are guaranteed by the extreme value theorem. So remember, the extreme value theorem says that if a function is continuous on a closed interval, it has to have a minimum maximum. Well, this gives us a process now of how to find the minimum and maximum. Essentially, that minimum and maximum, being global minimum and maxima, are going to have to also be local extreme. So if they're local extrema, we know they're going to have to be at critical points. And the other option then for our global extrema would be at the endpoints. So the only places that we could have a global maximum or a global minimum would either be at a critical point or at an endpoint. And based on that, we can find those extrema. All right, so that gives us what's called the candidates test. And it's called the candidates test because we start by identifying the candidates, the possibilities for the absolute extrema. So we find critical points that are on the interval. Okay, make sure that when we find critical points, we're not finding critical points that are irrelevant because they're outside of our interval. And we identify the endpoints. That's going to be pretty easy to do in these problems. And then we just figure out what is the value of the function at those points. Since these are the only 2 points, or the only 2 types of points where the extrema could occur, if we know the values of the function at those points, we just pick the biggest one as the absolute maximum and the smallest one as the absolute minimum. Notice that when we say minimum or maximum value, we're talking about the y value or the value of the function. So y value or value of the function, and then where it occurs is going to be the x value. So we want to make sure that we understand the language of the question and we answer the question the way it's asked. So if we're asked what is the maximum value of a function, we're looking for a y value. If we're asking where that maximum occurs, we're looking for the x value. Depending on the situation, either might be more important for solving some sort of application problem that we're going to be doing later.